the double Atwood's machine. So the double Atwood's machine consists of 2 pulleys and 3 masses attached to it, namely M1, M2, and M3. M1 and M2 has tension A attached to it to pulley A. Mass number 3 is attached to pulley B by tension B. So, first we need to take note that the pulleys have no mass. So, find A3, acceleration of mass 3. Next is acceleration of pulley A. Next is acceleration of box 1 and box 2. Then next is tension A and tension B. So the free body diagrams. So as we can see, mass 1 has its weight pulling it down and tension A pulling it up. Next is mass 2 with weight pulling it down, tension A. Mass 3 with its weight and tension B pulling it down. So pulley A has no mass, but it has tensions attached to it, which we can use as for the free body diagram with 2 TAs and 1 TB. Next, the equations. M1, we have M1G minus TA is equal to mass box 1 and times the acceleration of box 1. M2 is just the replicate of the equation of mass 1, just that we swap all the numbers 1 with 2. Same goes to number 3, but the tension involved in mass 3 is tension B. Next, the equation for pulley A is equal to 2 TA minus TB is equal to 0. Finding the fifth equation. So in finding the fifth equation, we need to take note that the string attached from the third box to pulley A has a certain length. So therefore we can say that the length of the string from pulley B to the third box plus the length of the string from pulley B to pulley A, which is XA, is equal to the length. We need to take the derivative of XA plus X3 is equal to length, so we can get the velocity of pulley A plus the velocity of the third box, which is equal to 0. The derivative of a constant is 0. So next we take the second derivative, which we'll get is A acceleration of pulley A plus the acceleration of box 3, which is equal to 0. Then we need to take note that acceleration of pulley A is equal to negative acceleration of box 3. So for strings of M1 and M2, we have M1 is equal to the length of the string from pulley B to the first box, minus the length of XA, which is the string from pulley B to pulley A. Next is M2, same goes for M2, it's X2 minus XA. Then we combine them, then take the derivatives and the second derivative. So X minus XA plus X2 minus XA is equal to, we labeled it the second length. So we'll get this after getting the second derivative is acceleration, the quantity acceleration of first mass minus acceleration of pulley A plus the quantity of acceleration of box 2, mass 2, minus the acceleration of pulley A, then it is equal to 0. Next, solving for A3. using the equation 5. So after taking the second derivative, we know that this equation has a relationship where we can use it. So a1 plus a2 is equal to 2 times the acceleration of pulley A. And we knew that acceleration A is equal to the negative acceleration of the third. So we can say that it is equal to the negative 2 times A3. So that this will be our fifth equation. So using the fifth equation, we solve for A3. So we will rearrange the equation. So we put negative 2A3 to this side, which will make it positive, and this term going to this side, which will make it negative. So inserting the equations. So inserting the equations from M1, M2, and M2. So in M1, we can find A1 by dividing both sides by M1. So we'll get G minus tension of pulley A over M1. Next is A2, dividing both sides by mass of the second box. We'll get G minus TA over M2. So we will use algebra to make the equation simpler too. So 2A3 is equal to the negative quantity of 2G minus TA times 1 over M1 plus 1 over M2. Then next, in the equation of pulley A, we can find a substitute for TA. So TA would be TB over 2. So next would be finding the quantity of TB, which will be equal to M3A3 minus M3G. But we can factor out M3, so we can get M3 over 2 times G minus A3 times 1 over M1 plus 1 over M2. Next is doing more algebra. So 2A3, the equation from last page, we multiply both sides by 2M1 M2, we'll get 4M1 M2 A3, which is equal to negative quantity of 4M1 M2 G minus G, the quantity G minus A3, multiplied again to the quantity of M2 times M3 plus M1 times M3. Next is isolate all with G variables and A3s. So next, we can see that here we have A3, here we have a G and an A3. So we'll use distribution, and then we'll get this M2 times M3 plus M1 plus times M3 plus 4M1 M2 times A3, which will become then equal to gravity times negative 4M1 M2 plus M2 M3 plus M1 M3. Next is we'll just divide this side, this G, this term by this term, so we can get A3. The answer then is G times negative 4M1 M2 over M1 M3 plus M2 M3 all over 4M1 M2 plus M1 M3 plus M2 M3. Then we also know that the acceleration of pulley A is equal to the negative of A3. Now, next is finding A1 and A2 and TA and TB. So, first TB. TB now is we knew that TB is equal to M3 times G minus A3, and also TA is equal to TB over 2. So the quantity of A3, we just need to substitute this by algebra, using algebra. Put this equation here. Then we'll get TB is equal to G times 8 M1 M2 M3 over 4 M1 M2 plus M1 M3 plus M2 M3. Next is TA. We just need to simply divide TB by 2. Next, finding A1. A1 is equal to G minus TA over M1. So we just put M1 TA here, then divide it by M1. Then we'll get G times quantity for M1 M2 minus 3M2 M3 plus M1 M3 all over 4 M1 M2 plus M1 M3 plus M2 M3. You'll arrive at this equation using some algebra. Next is A2, which is equal to G minus TA over M2. So we just need, from this equation, we'll just swap all 1's by 2's and all 2's by 1. So we'll get for M1 M2, nothing's changed here, but here we have negative 3 M1 M3 plus M2 M3, complete opposite of A1. So that's it. So here are the answers for all of our problems. A3, which is equal to G minus 4 M1 M2 plus M1 M3 plus M2 M3 over 4 M1 M2 plus M1 M3 plus M2 M3, then so on and so forth. Next is for the special case, we'll just have this. We can say in the special case is the mass of the first box is equal to the mass of the second box, then which is equal to M, and the mass of the third box is equal to 2M. So everything here will be substituted by these variables. So that's A1 is equal to G times 4M squared minus 3M squared, to 6M squared plus 2M squared over, that's 4M squared plus 2M squared plus 2M squared. Now A2 is equal to G times 4M squared minus 6M squared plus 2M squared over 8M squared. Next is A3, which is equal to the negative 4m squared plus 2m squared plus 2m squared over 8m squared. Then next is tension B is equal to G times 16m cubed over 8m squared. Then TA is equal to G times 16m squared over 8m squared times 1/2.